Welcome to this Rocket introduction. First of all, I'm kind of surprised to see so many people. That's good. So how many people have seen or watched a talk by me about Rocket? Nobody? That's good, because if you were, you were gonna hear the same things. Okay, so yeah, first of all, something about us. So I'm Iago, and he's...
Hi, I'm Alban.
Yeah, so we live in Berlin. We are two of the co-founders of, well, 2 out of 3 of the co-founders of Kinvolk. And we did a lot of work on Rocket with CoreOS and on Rocketlet too after that. And yeah, we're currently maintainers of Rocket and the Rocketlet. These are our GitHub pages and our Twitter, if you want to follow us. Although we don't really tweet much, but we retweet sometimes. So the plan for today is first, I would like to explain what is Rocket. Then I will move forward to explaining a bit of the Rocket internals, how does it work, how it's organized internally. Then I'll talk about what's new, or fairly new. And then what's missing, or what are the things that we think should be in the roadmap for the next, for the next months, I guess. So yeah, this is a catchphrase for Rocket. It's a modern, secure, composable container runtime. So to explain this a bit, with modern, we say that we try to take advantage of the latest technologies wherever possible. So things like in the Linux kernel, user namespaces, or seccomp, or the no new privilege flag. Those things that the Linux kernel made available for us, and they're new. We say that it's secure, as in we try to be secure by default. So all the security options are enabled by default. So yeah, sometimes that means that your app's not going to work, and you'll have to debug a bit why it's not working. But we think it's important that we make things as secure as possible by default. And by composable, we mean that we try to interact with the rest of the system in a good way. So we don't really try to reinvent the wheel. And if something is implemented in another part of the system, we just use that. So for example, we have a very good integration with systemd, because it's there and it does things that work, and we don't need to reinvent what it already does. Ultimately, Rocket is an implementation of the AppC spec. So before the OCI spec, there was the AppC spec. And back in the day, the Docker image format wasn't really specified. It was specified in the code, and that was not really ideal. So there was this effort from CoreOS to put out there a spec called AppC, and actually define the things that a container image and a container should be. And even though now it's kind of in a not deprecated, but not actively developed, we think it served as a first step towards standardization. And so now that the OCI spec is there, that's what you should be doing. But Rocket still implements the AppC spec. The parts of the spec that it implements is the image format and the execution environment. So just a quick word on AppC. As I said, it's a spec. It has some associated tooling. So we have things, we have the spec itself, and we have some code there that the implementations of the spec can use for image discovery and other stuff. We have also a server. We have a conversion from the Docker format to the ACI format. And CNI, you might know about CNI, is the networking used by Kubernetes, and it was born on the AppC, although it was moved later to container networking. So the AppC spec is 4 things, basically. An image format, which is the ACI. And an image is just a tarball with some manifest data attached. So the ACI is just that, a tarball with the rootfs and some manifest that explains what binary should be executed, how isolated should be the container, and things like that. A cool part of the AppC spec is the image discovery part. So instead of having a centralized registry where you just get your images from, what it does is it uses DNS as a discovery mechanism. So if you imagine your organization example and you have an app called app1, so example.com/app1 is your URL for the image. So what the AppSys spec will do is go to that web page and download some metadata there that will tell the runtime where the actual artifact of the image is. So this is a decentralized way of getting images instead of dealing with a centralized registry. Yeah, the AppSys spec also defines pods, which is, yeah, I guess you know pods because you are at KubeCon. Yeah, it's how you group applications together and run them together. And it also defines the executor, so the runtime, which is what's the environment of the app, what environment the app should find when it's running in a container. Yeah, so Rocket is just a simple CLI tool. There's no daemon involved. You just run Rocket, and it just runs there, whatever you under the process that spawned Rocket. It's just it's implemented in Golang, and it's only supporting Linux. So we didn't want to support other operating systems like OpenBSD or Windows or Mac. It's self-contained, so it only requires minimal set of libraries like libc and a couple more that should be installed on every Linux. And it's init system and distro agnostic, so it should work everywhere, even though we optimize for systemd. Yeah, as I said, there's no mandatory daemons. So this is the tree of processes that appear when you run Rocket. So you have bash, systemd, or runit, your init system, or your shell. And then Rocket will run a pod, and then the pod will have several apps. So you see there's the word stages here. So the stage 0, which is a Rocket binary, and that deals with just discovering where the image is, fetching the image, managing it, like you can list the images, remove what you expect from a container runtime. It also sets up the pod file systems, so it renders the pod to the file system, so you can actually start a container there. Then there's stage 1, which is the actual exec environment for pods, and this is what we call a pod. That's where the isolation is. So in stage 1, you can, the actual container will start. It also manages the lifecycle of the processes inside a container. So, for example, sometimes you want that if a process dies, the container dies, or maybe you want it to restart it. So that's handled by stage 1. And it also applies the resource constraints. So if you want to limit the amount of memory that a container is taking, or the CPU, that's stage 1's role. And then stage 2 is just the actual application, so whatever you run, Nginx or any application. So one cool thing about stage 1 is that it's swappable. So the default implementation uses Linux namespaces and secrets for isolation. So that's what you call a Linux container. And it's based on systemd and spawn, and runs systemd inside to supervise those processes, as I mentioned before. But there's also different implementations. There's a KVM implementation. So instead of using Linux containers, it uses virtualization, so hardware virtualization. First, it was based on LKVM, which is a lightweight KVM binary by Google, I think. But then we switched to QEMU because we had some troubles there. LKVM had some nasty bugs. So this was pretty cool because the design of Rocket made easy to just swap systemd and spawn with QEMU binary, and things just work. And you can take advantage of the Rocket distribution, image distribution mechanisms and all that, and signing. And then there's Fly, which is just something that you take advantage of the image distribution mechanism, as I mentioned. It's just a CH root. There's no security guarantees involved. So, for example, Fly is what used if you run CoreOS container Linux. It's what used to run the kubelet via the kubelet wrapper script, and also I think etcd. And then there's others. There's some experimental ones. Yeah, you can search for them. So yeah, what happened in Rocket recently? So we implemented sharing the host IPC namespace. This was not possible before because systemd and spawn wasn't allowing that. So we implemented this for a client that wanted to have some HPC, high-performance computing tasks running, and they heavily use shared memory. So yeah, we did that to allow that. And also, so the Rocketlet is the Rocket implementation of a Kubernetes CRI, so container runtime interface. So yeah, in order to make that work, we need to fix a lot of stuff in Rocket because the design of Rocket and the CRI weren't really matching. So we had to redesign Rocket a bit to allow sandbox to be created and then containers being added on top instead of just creating an immutable pod, which was what Rocket was designed for. We also switched the default KVM flavor from LKVM to QEMU. I mentioned that. And we fixed a lot of bugs. Another recent development we did was documentation. So yes, documentation is important. And things were documented, but not as deep as they could be. So we actually have to thank the CNCF for this, because this work was funded by them. And yeah, as you can see, we had a lot of issues about documentation. We have 31 PRs. Well, actually, yeah, I don't think there are issues or PRs, but yeah, a lot of stuff. Yeah, so what is missing in Rocket? First, one of the most urgent things, I guess, is updating the CNI version, because Rocket is using 0.3, and that's pretty old. And in 0.6, there's some new features that users want. But yeah, we haven't gotten around to it yet, but because some vendoring issues and a lot of changes on the CNI. Another thing that's missing is to implement the Rocketlet support. We did some new features that are guarded by some environment variables. Those are the Rocket experiment environment variables. Yeah, so we think that those work fine. Maybe it can be improved a bit. So we should remove those environment variables so it just works out of the box. Those features are needed. And then Casey from CoreOS started experimenting using runc to run the stage 2. And the reason for this is, so we were taking the parameters for Rocket and translating those to fields in a systemd unit. And sometimes the parameters needed don't really match. So yeah, using runc will avoid that and will make things work better. But yeah, it's just in an experimental state, so it doesn't really work at the moment. And then Rocket supports the OCI image spec, but only through converting Docker images to the ACI that's used internally in Rocket. So there was some interest in doing some native OCI support, but I don't think work has started yet there. And then, of course, always general bug fixing. So I'm going to do a small demo now, and then I will try to answer questions. Maybe you have questions about the future of Rocket or things like that, so I will try to answer those as better as I can. So let me share my terminal. Okay, you can see that. I guess I'll do it bigger. Okay, so this demo is kind of a mix of things. So we have a cluster, a Kubernetes cluster running the Rocketlet. And this is running in containers. So on my machine, I have a tool called kubespawn that we at Kinvolk developed. And this tool can start multi-node clusters on your machine. So it's think of it like Minikube, but for multi-node clusters and using containers instead of VMs. So I have 3 of those machines. So I have a master and 2 workers. And yeah, actually, it's also running Flatcar Linux, which is a fork of Container Linux that we at Kinvolk did. Because since the acquisition by Red Hat, yeah, so there's not going to be commercial support for Container Linux. So we are trying to take over there. So it's basically just like Container Linux, but with the names changed. And we try to be as close as upstream as possible, as long as upstream exists. So yeah, recapping, I have 3 containers, 3 OS containers. They're running Flatcar Linux, and one of those is the master, and the other 2 are the workers. So I can actually enter one of those. Yeah, so here we are. And I can run Docker images, for example, and to make sure that nothing is running there, nothing Docker. So if I actually check in Rocket, well, it's maybe a bit big, but you can see all the components of a Kubernetes cluster. You have the CD, we have the scheduler, we have kubedns, we have Weave. We use Weave as a network here in this example. So yeah, this is all running in Rocket. So yeah, so these are all the pods that are running. And yeah, it's just a simple demo to show that the Rocketlet works fine as a runtime for Kubernetes. We have some problems with Kubernetes 1.10 that was recently released, but this is 1.9 and it works fine. And yeah, we should fix those problems soon. And I just have an Nginx pod, just a typical example. And I also have an Nginx service that is a node port service. So yeah, I can show that it works. So the port exposed is this one. And I can check the IP of one of the nodes. So, sorry, my clipboard. Yeah, and it's just welcome to Nginx, yay. So yeah, that was the demo. Unless you want to show, you want to see something specific. Yeah, so at the moment, Rocket is receiving not many contributions because CoreOS only supports it as far as they need for their Container Linux needs. So we do some basic maintenance, like maybe reviewing some PRs and doing some small releases. And then we at Kinvolk, we currently don't have financiation to carry on development full time. So yeah, it's a CNCF project, so it should be. I guess we were hoping that the community will pick it up and use it. But yeah, I think this has not happened yet. So that's what the only thing I can say about the future of Rocket. We like it a lot, but we don't really have the time to spend on developing it full time. And if you like to pick it up, or if you want to use it and maybe make it gain more traction, please feel free. Yeah, otherwise it will stay there, I guess. I think some people still use it, and we sometimes receive stories from people that use it. But either it works fine for them, or yeah, they don't need any new features. So yeah. And with that, yeah, maybe you have any questions or comments. I will try to reply. Yes?
One question.
So a question about mounting volumes. Yeah, that's supported. Yeah, it's just a basic feature of Rocket. So, was that your question? If it was supported? Yeah. Okay. Thank you. Okay. Yeah, there's a question there. So this is a question about the advantages of using Rocket against Docker or other runtimes. So yeah, we think Rocket is pretty focused on just being just doing the containers and that's it. So in Docker, you have a lot of things in the Docker daemon. Like the Docker daemon itself fetches images and it keeps running there. And then if it crashes, maybe your containers crash too. And it also does. Yeah, it does a lot of things. So Rocket is pretty focused. It's just a process that does maybe the image fetching and then runs and then stays out of the way. So that's one advantage from our point of view. Then we also like this stage 1 swappability, so that it's easy to experiment with new runtimes. So I don't know if you heard about this new runtime by Google. That's a sandbox runtime. Yeah, I think it will be pretty easy to just do a stage 1 with that thing, and yeah, so it's a good way to experiment with new concepts. And I'm also a bit yeah, well, maybe not disappointed, but yeah, I don't like that in the OCI image spec distribution spec, an idea like the image distribution for ACIs wasn't considered. Because I think a distributed image distribution, well, yeah, a distributed approach to image distribution was very interesting, and they just follow Docker with the central registry idea. So that's kind of a shame. Yeah, so in summarizing, I think if you just need to run containers and you don't need anything fancy around it, you can use Rocket. If you are concerned about the stability of Docker, like sometimes when they do upgrades, they break some stuff, and people are not really happy about that. Maybe you can consider giving Rocket a try. And yeah, that's basically it. Cool.
There will be another presentation in the afternoon about Rocket. And there will be some diagrams showing a bit more about the architecture.
Yeah, so if you're interested in knowing how containers work, like in a more deep way, you can come to the Rocket Deep Dive. We will be talking about C groups, SD Notify, and yeah, a lot of cool stuff with diagrams. And it will be more like a discussion session where if you're interested in a topic, you can talk about it and we can try to explain how this works. Yeah, so if you're interested in that, please come. Cool. So if there's no more questions, thank you, and see you.